And welcome back as we continue our journey through astronomy. Let's go ahead and take a quick discussion on how we handle numbers in astronomy. So the very first thing to familiarize ourselves with, if you're not familiar with already, is scientific notation. In astronomy, because we tend to deal with distances on a scale with numbers larger than any you may have encountered before, we need to have a different methodology for handling these really large numbers than simply writing them out. So there's two approaches that we can adopt, which will actually make dealing with astronomical numbers a little bit easier. First off, we're going to use scientific notation. This is a system that can be very appealing because it eliminates the many zeros that can very easily seem overwhelming to readers. So for example, instead of saying 500 million, we can write that as 5 times 10 to the power of 8. That exponent, the 8 there, will actually keep track of the number of places we had to move the decimal point to the left to convert 500 million to just 5. Now, we do need to talk also about common units. This is the second approach that we need to use. And if we start thinking about the units of measurement that we want to use, if we think about our everyday life, for example, we probably use something more like, hey, I'm going to measure the distance of something, and I might use something like maybe centimeters, meters, kilometers. But on the cosmic scale, we're not going to necessarily use those smaller units. Because if we think about these vast distances that we have to use between like all the different stars and galaxies and stuff like that, the common unit that we tend to refer to is a light year. And the light year is simply just going to be the distance that light travels in 1 year. Now, light is always traveling at a constant speed and is also coincidentally the fastest speed possible in the universe. So because we know how fast light can go, it makes for a good standard that we can use to keep track of distances. So let's keep all this in mind and put this a little bit into perspective about how exactly big is the universe. So let's start by asking how many kilometers are there in a light year, because a kilometer is something we might have a little bit more familiarity about how far that is. Well, light travels at an amazing pace of 3 times 10 to the kilometers per second, which means that a light year is 9.46 times 10 to the 12th kilometers. Now, that seems like a pretty big number. And you're like, well, that's pretty fast, right? So we should be able to reach the nearest star pretty quickly, right? Wrong. Because the distances between stars is far more remote than you might think. For example, our nearest star from our home is about 4.25 light years away, or more than 40 trillion kilometers. That's quite a distance there. Now, other stars that we see in the night sky, that even just using our unaided eye, not using any telescopes or anything like that, are typically going to be anywhere from hundreds to thousands of light years away, which again means that what we're looking up and seeing is an extremely remote distance. That also should kind of give you an idea of how bright these objects are to be able to see at such a long span. And so let's look at this with a cosmic example here. So the Orion Nebula is actually a cloud of cosmic raw material. So it's gas and dust, which pretty much makes new stars and planets and stuff like that. Now, the Orion Nebula, even though we can see it, is about 1,400 light years away, which means if I were to convert this to kilometers, that's roughly 1.34 times 10 to the 16th kilometers. Now, if we could actually look at this region of space, the gas and dust in this region is illuminated, and the reason why we see it so well is because there's intense light from the very few extremely energetic adolescent stars. And we say that adolescent because when we have gas clouds like this, they tend to be very young. So we have very young stars here, and because they're very young, you notice we also have a lot of bright light coming out of here, which illuminates the gas that we're seeing around it.